You are listening to the HYDAC podcast. In each episode, we share our knowledge with you in topics related to hydraulics and automation and control, from the basics to the current trends. Stay tuned. Welcome to this episode of HYDAC podcast. I'm your host, William Shaw, and on this episode, we will be discussing what is a sensor and where are they found. Today in our studio, I have Mr. Dimitri Levitt. Dimitri is a mechatronics engineer with over 9 years experience in automation and control system design and works for HYDAC as the National Development Manager for Automation and Control in the Industrial Internet of Things. Welcome, Dimitri, and thank you for your time today. Firstly, I'd like to start with, what is a sensor? Able to tell us a bit about what they are?
Hello, William, and hello, everybody. What is a sensor? A sensor is something that measures a real-world physical property, and in some cases, it'll actually send that measurement via an electrical signal to a computer-based system.
So what are some of the common types of sensors that people in everyday life come across and may not realise that they are actually sensors?
Well, William, people come across sensors pretty much quite often in everyday life. Like, for example, if you drive a car, when you pull up to a traffic light, there's a sensor in the ground, an inductive loop, which detects the presence of a car. And even if when you're walking to a car, some of the cars have, they unlock automatically when you reach out your hand to the door handle. That's generally a capacitive style sensor. And there's also sensors in like a switch sensor in the button where you need to press to, say, cross the road or pedestrian crossing. Or when you walk into a store, that beeping noise that you hear when you walk in, that's a photoelectric sensor. And at self-checkouts or in a checkout at a supermarket, the barcode scanner is a sensor. So in everyday life, we come across a lot of sensors, and it's just interesting how much they add to our daily lives.
So just bringing it back to the industrial sector and for hydraulic applications, what are some of the common types of sensors that we would see in this type of environment?
So in industrial sectors, you may come across sensors like temperature sensors, pressure sensors, flow, speed, level, even position sensors that detect how many cans of beer might will go past in a production line. So there's a lot of different style of sensors within the industrial, and then there's also advanced sensors like vision detection, object detection sensors. So it's quite a broad, there's a huge array of sensors that could be used in the industrial and hydraulic sectors.
So what would be some of the reasons that people would use sensors in their applications?
Well, I guess some of the reasons could be to gather information or to count how many products have been produced in a production line, for example. Or let's say if you're trying to control a hydraulic power unit or something to a particular pressure, you need to know what the actual physical pressure is in the system. So you need to put a pressure sensor to control that loop. Or, for example, you need to control the pump or the displacement of the pump to actually control the pressure in the system and things like that. So, but then the other part is, once you have an array of sensors, you can automate something. You could data log and things like that. So it depends on the style of what you're trying to achieve.
So why would people want to automate? What are some of the benefits behind automation?
Well, William, I guess some of the benefits, why you'd want to automate something is you'd probably want to introduce efficiencies or quality or repeatable quality in your process. A sensor removes the variance of, say, an operator, where if you need to control something at a particular pressure or temperature, someone may touch something or push back against something, they may feel that differently to the next operator, for example, or the sound of something. But if you have a sensor, it'll always read the value reliably and it will be repeatable. So that's probably one of the main benefits. And one of the other things is maybe in the future, if you've automated something, you want to make it into a full autonomous machine, but that is a different ballgame altogether.
So do sensors have different types of outputs or electrical signals that can be measured?
Yes, so there are a number of types of outputs that can come out from a sensor that would be sent to another system. For example, there is analog and digital outputs. Analog in terms of a current or a voltage output, and generally this is a scaled value or a representation of the real world value that a that can be read in another system, or a digital output, which is like an on-off. For example, most of the time, digital outputs, like a good resemblance or something of a digital output, is the inductive loop that's in the ground when your car pulls up to the traffic light. It detects that your car's there, and it sends an on signal to the traffic control system to switch the traffic light. And a real world example of an analog output could be something, for example, in your car, the fuel gauge. The sensor that's detecting the fuel level in the car is sending an analog signal to the car's control system or computer, and then it's displaying that either in a digital value or a needle gauge, and that's what we call an analog signal.
You mentioned earlier that sensors send the signal to a computer-based system. What do you mean by this?
Well, I meant in terms of the computer-based system. So a computer-based system is in our world, or in the industrial world, is a programmable logic controller. Is a device that will read this signal, so either an analog or a digital signal, and can make a decision based with that signal on the decision that you've programmed it to do. So, cars have what we call electronic control units. That is effectively a programmable logic controller, but sits in a car. And same with, the rail signaling systems run on programmable logic controllers, and the traffic management systems as well. So, and in every industrial plant, you'll find a programmable logic controller that actually automates the process, does the control loops, monitors the signals coming from a lot of sensors, and makes the decisions that you've programmed that programmable logic controller to do.
So that's the end of our podcast. Thank you, Dimitri, very much for your time. Please join us next time where we discuss smart sensors and IO-Link. Thanks for joining us on this episode of HIDAC Podcast. For an in-depth learning on the subject you've just listened to, enrol on the technical training at HIDAC Australia. For more information, visit our website, hidac.com.au. HIDAC, global presence, local competence.